Okay, let's move on and look at this figure. The figure is formed by a circle and an isosceles triangle where PQ is equals to PR. So as I read, I will look at the figure because it's really no point reading the whole question and then don't know what they're talking about, okay? So the figure is formed by a circle, so this is what I'll do. Okay, there's a circle, okay? Just like doing a stock take. And an isosceles triangle. So where's the triangle? Here. And they say that this triangle is an isosceles triangle. So review, what is an isosceles triangle? An isosceles triangle is one where you have two of the sides that are equal. So this is a triangle, and where is the equal part? Is it this and this, or is it this and this, or is it this and this? Well, the question tells you, if you read carefully, they say PQ is equals to PR. PQ is here. PQ. And then they say PR. PR is here. Alright? So this is equal to this. That's the isosceles triangle. Okay, and I continue reading. They say the radius of the circle is 14 centimeters. Now, where's the radius of the circle? The radius means what? From the center of the circle to the side, right? So from the center to the side, this is 14 centimeters. From the center to the side, that's 14 centimeters. From the center to the side here is 14 centimeters. You see that? Okay, so write it down. This is 14 centimeters. This is 14 centimeters. And because this is the same as this, I know that this diameter is what? 28, right? 14 plus 14 is 28. So I know that this is actually 28 centimeters. You see, one thing leads to another if you are able to read with meaning. Okay, now find the area of the shaded part. Okay, so now we just go direct. Okay, find the area of the shaded part. So what I probably will do is I'll say, okay, I want to look for this part. It looks easier. How do I look for this part? Can I take a semicircle, then I minus off this shape? But how do I find this shape? I don't know. Okay, or can I take this shape, this triangle, then I minus this shape? But it's the same shape, and I also don't know what it is. Okay, so how am I supposed to do this? Right, if I go direct like this, if I can't figure something out, then I'll try to think of another method. Okay, maybe I could cut and paste. Okay, so I'll try to figure out that, okay, how do I cut and paste? Can I cut this and paste them somewhere? Okay, when I was trying this question, I wanted to take this and then flip over and say, hey, maybe they are the same, but of course they are not the same, right? Okay, I can't do this. Okay, it was just a wild idea. Okay, then you have to think of maybe I can take this and put it somewhere. Where can I put it? Well, this is a semicircle. This is right in the middle. So if I were to draw a line here, okay, look, if I were to draw a line here, wouldn't this shape be the same as this shape? Yes, right? Okay, so what I can do is I can cross out this one. Okay, I can cross this one out. I purposely use blue so that it looks like as though it's the... Okay, and then I can put it here. What's this method called? Cut and paste. Okay, and ta-da! What do I have? I have a triangle. Now, don't be so happy yet, because sometimes in this kind of figure, when you see a triangle, you don't have the dimensions. If you don't have the dimensions, means the length and the height, the base and the height. If you don't have it, you can't find the area. So once I form a triangle, I'll be very happy, but I will just hold it first, okay? Just look at it and say, where's my base and my height? To find triangle, I need half times base times height, my blueprint, right? Okay, so I will look for the base. Base and height must form a right angle. Top of the triangle, drop an anchor down. Okay, so I have half. What's the base? If I look at this triangle, I might want to turn the paper. You can turn your worksheet. Okay, don't turn your computer, turn the worksheet. Okay, so here, this will be the base, right? Okay, so once you turn, you know that, oh, the base is 28. And where's the height? This will be the top of the triangle. Drop an anchor down so that it can form a right angle. All right, so what do you think this is? 14. Okay, so it's 14. You see that? So cancel 1, cancel 7. You have 28 times 7. 8 times 7, 56. 2 times 7, 14. 14 plus 5, 19. Okay, and there you have it, the area of the shaded part, 196 square centimeters. Okay, now let's continue on this question. There are two circles, X and Y, with radius R, small r, and big R respectively. Go and look at the picture. Two circles, small r, big R. Why are the radii different? Because one is a smaller circle and one is a bigger circle, right? So that's why they are different. Okay. Although if you look like that, it looks as though they are the same length, but they're actually not. Okay. This is optical illusion. All right. The ratio of R, the small r, to the big R is 4:7. Okay. I remember when I was teaching. Okay. In fact, I tell my students a lot of this. Okay. I say that fractions, decimals, ratio, percentage, all these 4 topics are interrelated. And these 4 topics are like ants, you know. I call them the 4 monsters, okay? They are like ants, they're all over the place. Okay, you will see any of these in any kind of question. It can be in average, it can be in circles, it can be in area and perimeter, it can happen in geometry, anywhere. All right, so if you want to do well in your maths, you have to make sure you're friends with these 4 monsters. Okay, so there you have it, you have a ratio. And in this topic called area of circles. Okay, now if the area of X is 169 pi square centimeters, find R, okay, a big R. Okay, so where is that clue? I have 2 clues. Okay, the first clue that they gave me is this, the ratio. The second clue that they give me is area of X is this. Okay, so I have to make use of these clues to find the length of this. Of course, if I want to find the length of this, the easiest is if I know the perimeter or I know the area of this circle. Okay, but I don't. All I know is the area of this circle. So how? How does it help? If I know the area of this circle, what can it help me to find? It can help me to find the small radius, right? Okay, so if I know the small radius and the question tells me the ratio of the small radius to the big radius, then I will be able to find that big radius. Okay, so this is all that's going on in my head, my blueprint. Okay, so that plan. So then I will write it out. For example, I will write something like this. Area of X, okay, is actually pi r squared. Correct? That's the formula. That's why I say formula is very important. Okay, so the question tells me the pi r squared of X is actually 169. Right? So I say, okay, pi times r is equal to 169 times pi. Agree? This is like glue. See, algebra. This is like the glue, right? So it's 169 times pi. So I write it this way, and I see the relation between them. Do you see that this pi is the same as this pi? So I can actually rewrite it like r times pi is equal to 169 times pi. So therefore, r times r is actually 169. You see that? If r times r is 169, then what's r? R and R, these two must be the same, okay? So this is where you have to work on your mental calculation. A lot of people will say, I know, 169 divided by 2. That's wrong, okay? That will be r plus r, okay? This is where you use your algebra. Okay, remember the rules from algebra? Yeah, that's very important, okay? So these two numbers must be the same. So you have to go 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10, we are not there yet. 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169. Did I say 169? Yes, okay, so that's 13 times 13. Okay, so I know that this small radius is 13 centimeters. Okay, so multiplication is very important, okay? The doubles are very important, right? One of the first things I make my students learn in multiplication table is the doubles. Okay, they must be able to tell me 2 times 2, 3 times 3, 4 times 4, all the way until 13 times 13. If better still, if you can do 15 times 15, okay? I'm only until 13 times 13. 14 times 14, sometimes I get it, sometimes I don't. Okay, my CPU is a bit rusty. All right, so let's look at big R, okay, the big radius. How do I get the information? From this clue, okay, from this clue. So they say the small r is to the big R is 4 is to 7. Okay, so 4 unit is to 7 units, right? Okay, now then they say that, okay, so the small radius is 13 centimeters. Then what's the big radius? So if 4 unit is 13 centimeters, what is 7 units? Okay, 4 unit is 13 centimeters. Then 7 unit is, what does this look like? This looks like inverted 7, you know. Okay, your unit, right? So you find 1 unit, 13 divided by 4. And then you want 7 units, so you times 7. So 13 divided by 4 times 7. Okay, can't cancel anything, so you just have to multiply. 13 times 7 gives you 21, 7, 91 over 4. Then what are you going to do with this? You're going to change it to mixed numbers. Okay, so that's 91 divided by 4. 2, 8, 11, 2, 8, 3. That's 3 quarter. Okay, so that's 22 and 3 quarter. Is that my answer? Yes, it is. Okay, so this is 22 and 3 quarter centimeters. Okay, so this is an unusual question. You have a lot of the things from other topics. It's a very short question, but a lot of information from other topics that you have to bring in into this question in order to help you to solve it. Okay, so don't just think that when you do circles, you're just, you know, in a well, circle well, and then you just look at circles. Not true. Okay, other things can come in. Now let's take a break and then come back for more. Now let's take a look at this picture. The figure is made up of a square and two identical quadrants of radius 21 centimeters. Okay, let's look for the square. Where's the square? This one, right? This has to be the square. So if this is y centimeters, this has to be y centimeters. And then they say, and two identical quadrants. Identical means exactly the same. Quadrants means quarter circle. So this obviously will be the quadrant. And then this is the other quadrant. You see that? Okay, so the question is that you're supposed to take pi to be 22/7 and A, find the area of the figure. If there's an A, means there should be a B. Okay, let's not worry about the B. Let's look at A. Okay, so squares there. All right, so I might want to write that this is also y centimeters because it's a square. All right, and then they say that the radius is 21 centimeters. Where's the radius? Now the radius is actually this part here. This. See it? Okay, so this is 21 centimeters. Of course, this is also the radius, 21 centimeters. Maybe it's better for me to write this in white so that you can see it very clearly. This is y centimeters. Okay? All right. Now, then you're supposed to find the area of the figure. Now, what's the area of the figure? The area of the figure is actually not the quadrant plus the quadrant. It is not. Okay, the area of the figure is actually this shape. This is called the figure. Yes? Okay, so that's the figure. How do we find? If we go direct, is it possible? It's not possible. But since I have two quadrants, it might make sense for me to find what's the area of one of the quadrants first. Okay, to find a quadrant is actually 1/4 pi r squared, right? So it's 1/4 times 22/7 times, what's the radius? What's the radius of this? The question tells me, the question says that it is 21. So I times 21 times 21. Okay, so I cancel by 7, I get 1. By 7, I get 3. By 2, I get 2. By 2, I get 11. So I now have 11 times 21 times 3 divided by 2. Okay, so here I can do 11 times 63 over 2, which is 693 over 2, right? That will be 3 and then 4, 6.5. Okay, 346.5 square centimeters. That's for one of the quadrant. That's for this part here. You see that? Now, my job is to find this little one and this little one. Okay, how am I supposed to find these little ones? Now, there are various ways to do it. Okay, if you want to look at the superimposing, you can actually see this. Can you see that this is actually the quadrant? So if you take out the square, if you take out this square, you will have this part, and that's what you want. Am I right? So that's one way of looking at it. The other way of looking at it is, I can also find the quadrant. Okay, I find this quadrant, then I add them up. I add this quadrant to that quadrant. Okay, so I have two quadrants. The two quadrants means that I have this, okay, and this. Yellow, okay? This yellow part is also 346.5. But is that, after I've added these two up, is that the area of the figure? No, because notice that this is just pink, this is just pink, this is just yellow, this is just yellow, but here, there's pink and there's yellow, the square, right? Okay, why is it so? Because I counted it twice. But does the question want me to count it twice? Because there's this superimposing that fits like that. Does the question want me to count it twice? No, I have to remove one piece. It's like taking two pieces of paper, okay, and then you find the area of this, you find the area of this, and then you put them together, okay? And then what you need to do is you need to cut out, take out this piece, and you still have this piece there. Okay? So you understand? Now, so what I'll do is, this is a lot easier because the calculation is easier. So I'll take 346.5 times 2. Okay, so when I multiply by 2, I'll get 693. How do I get it so fast? There, it's here. I took 693 divided by 2, right? So it's this. So if now I take this one times 2, it's of course 693. But that's not done because I need to take out one of the square. There are 2 squares here. You see that? I'm going to take out one of the squares. So how do I take out one of the squares? I might need to erase it so that you can see clearly. Okay? So where's the square? This is the square. What's the dimension of the square? Y and y. So to find the area of the square, it will be y squared, correct? Y times y equals to y squared. This is algebra. Okay? Now to find the area of the figure, that means this blue color figure, it would be taking the area of the quadrant, which is 693, and I minus away one of the square, okay? And then I bracket it up and say, okay, this is my answer. Okay? So this is algebra into play plus superimposing. All right, you have to be able to tell that. Okay? Now let's take a look at this one. It says find the perimeter of the figure. I'm sure you guessed it, right? A says find the area of the figure. B usually to find the perimeter. Perimeter means the outline. Okay? I'm sure you're quite familiar with this picture already, given the last question. Okay, the figure is made up of a square, of course you know, and then 2 identical quadrants of radius 21 centimeters. Now, perimeter. Perimeter means outline. Outline, so I will outline, okay? So I will do, oh, I am looking for this. What is this? This is a quadrant, right? And then I'm also looking for this. Hey, there's another quadrant. So 2 quadrants will give me a semicircle, correct? Okay, so I'm supposed to look for the semicircle. That's easy. To find a semicircle, it's actually half pi d, correct? So I'll just fit in all the information because in my blueprint, I know that, oh, I'm looking for this. Then I'm also looking for that little v and a v, okay? So there's a v here and a v here, right? So sometimes, instead of writing the big plan, this is like not a very difficult question. So sometimes I do use my highlighter, especially when it comes to perimeter. Okay, I will use my highlighter, I'll highlight, okay, this is what I'm looking for. Okay, and then after that, okay, what's missing? Okay, the V. How am I supposed to find the V? All right, then I'll put everything together. Okay, that's also possible. Okay, so half pi d, so I'll have half. Pi is 22 over 7. And the diameter of this quadrant, or this semicircle, they say the radius is 21. 2 radii make 1 diameter. So 21 times 2 is 42. Okay, so if I work it out, this is 7, that's 6. So that's 66 centimeters. Now this is perimeter, this is circumference. Okay, just the yellow parts. Right, now I want to look for that V, right? Okay, so I want to look for this part. Do I know what's this? This is the radius, which is 21. Okay, and I also know that this is Y, correct? So therefore, I actually know what is this line here. This line is 21 minus y, correct? 21, that's here, minus away the y, will give me this. And how many of this little pink squiggly do I have? 2, 3, 4. And if I know these 4, I will be able to add it to 66 and find my answer. So to find 4 of it, I'll just have to times 4. Okay, so 21 times 4 is 84. Y times 4 is 4y. Okay, so once I have this, then I need to add it to this. Okay, this is centimeters. So I need to add it up. So I have 66, which is all the yellow lines, okay, plus 84 minus 4y, which is all the pink lines. Okay, so 66 plus 84 gives me 150 minus 4y. And you will remember from your algebra, you got to bracket it up and put centimeters. Okay? So it's algebra actually. The calculation is algebra, but of course you have to make use of your circles, your formulas for circles, okay, to help you. Now, ratio. It says in the figure, the ratio of the area of circle P to circle Q to circle R is 3:4:10. If 1/3 of Q is shaded, what is the ratio of the shaded part of the unshaded part to the total figure? Okay, so that's a bit of a mouthful, but doesn't matter. I don't really care about this part yet until I figure out what this is talking about. So they say in the figure, the ratio of the area of circle P is here. The area of circle P is this whole thing. To circle Q, which is this whole thing, that, oh, there's an overlap. Okay, and circle R is this whole thing. P and Q are inside R. Okay, so these are things that you have to be very clear about. So it doesn't matter. I'll just write P, Q, and R. 3:4:10. Okay, then I read on. They say if 1/3 of Q is shaded, so 1/3 of Q is shaded, the other side must be unshaded. And they say this is 1 and this will be 2. Now, if you recall from my ratio questions, all right, I would say that there's this a magic triangle. It doesn't make sense, right? How can 4 be made into 1 and 2? That's 3 parts only. Okay, so I have to change to a common multiple, which is 4 and 3. The common multiple is 12. Okay, so this one is because I times 3. So here I must times 3 to make it 9. Here I times 3 to make it 30. Now this is 3. I want to make it into 12. I times 4 and I times 4. Okay, now it's nice because I have 9 units of P, 12 units of Q, shaded is 4, unshaded is 8. Okay, and then this is 30. Now, usually what I like to do is I'll take a pencil and I try to fill in all the parts because it's clearer when you fill it into the picture. Okay, so the only part that I have that is shaded is this one, 4, right? So I'll write inside here 4. And then this is part of Q, isn't it? Q has how many? Q has 12. So if 4 are shaded, there will be 8 that's not shaded, right? When I say 8, I'm talking about this part. I'm just talking about this part here. So if you take 8 plus 4, you still get 12. Okay? Now let's look at P. Where is P? This is P, inclusive of this shaded part. So P is supposed to be 9, but 4 is already taken for the shaded. This will be 5. Alright? Now, then we look at R. The whole of R is 30. This whole thing is 30. But 30 is inclusive of 8, 4, and 5. What is 8 plus 4 plus 5? That's 17. Okay, so it's 17. So you have 30 minus 17, you get 13. Okay, so just do a quick count in case we counted wrongly. Okay, when you add this to this to this to this, you must have 30. Okay, so let's count. That's 9, 10, 17, 17 plus 3, 20 plus 10, 30. So we are there. Okay, so I've got all of the figures. Now let's see what the question is asking for. The question is asking for number 1, the shaded part. So the shaded part is 4, obviously. Okay, then they're looking for the unshaded part. Where's the unshaded part? The unshaded part will be this and this and this. Correct? So you take 13 plus 8, 21. 21 plus 5, 26. And then the last one is the total figure. The total figure. What is the total figure? The total figure means this whole thing. This whole thing. Is it Q plus a P plus Q plus R? The total figure is this whole thing, which is actually 30. Okay, a lot of students will do it wrongly because they will think that it is actually 9 plus 12 plus 30. No, because P and Q are inside R, and that makes the entire figure. Okay, so you don't take 9 plus 12 plus 30, just take 30. That is the total figure. Okay, then you reduce it because all of them are even numbers by 2, 2 by 2, 13 by 2, 15. Okay, the difficult part is in the shaded and unshaded and how once the smaller one is embedded in the bigger one. So that needs a lot of clarity. Okay, and for me, I like to write it in the figure with a pencil so that it's clear for me. Okay, I know exactly what I'm referring to, which area I'm referring to.